Hello, this is the third video of a linear programming series of the OCR Discrete Further Maths. It looks at using an objective line method within the graphical solution process. This is a linear programming problem in the right formulation of decision variables, objective function, and constraints, which was used in the previous video. Here is the graph for that linear programming problem. We'll note that the feasible region is all of the coordinates that lie in the unshaded area, and each coordinate xy represents the numbers of each type of shed made. We expected to find the maximum values of p, the objective function or profit, at a vertex to this shape. We could identify the feasible region having plotted the constraints and decided which side of the line to shade. We've already seen the vertex method in the last video for finding the optimal solution within this region. However, checking several vertices can be time-consuming, especially if we have to solve simultaneous equations. Even if it's acceptable to use a calculator for solving these, provided the equations being solved are also clearly indicated in the solution. A variation on this method is to use an objective line to determine the optimal vertex before solving. To do this, we need to draw the objective function line. For example, the 60x plus 84y equals p. Now, to draw the line, we can pick p to be any value that's helpful. It makes no difference. The objective line is shown here in green. Once you've drawn the line with the ruler, slide the ruler to the last point available in the feasible region, keeping it parallel. So, for example, very carefully sliding that ruler in this direction, keeping parallel, always sliding this way, you should see that when the ruler's about here, it will have gone past the 12, 0 and gone past the 0, 10, and that as it's just leaving the feasible region, the last point it will hit is this vertex here, the 6, 6. That would then alert you that that was the optimum solution vertex. The vertex that the ruler touches last as it slides out of the feasible region will give you the values of x and y that will optimize the function and hence the profit. In this example, as we found in the last video, x equals 6, y equals 6, and the maximum profit is found by putting these values in to the objective function, with a result of 864 profit. Whether you use the vertex method on its own or the vertex method with the help of the objective line method first, you will get the same results. In the next session 1.4, we will consider how to find integer solutions where these are required by the question context, but may not be the optimal solution found by the graphical approach.